Welcome back to my channel, everyone. Sri Tips here, and what we're going to do to start this off is break these chips up with a hammer. If you're emotionally, some people are emotionally attached to these chips, and if you're like that, please don't roast me here. I bought these specifically for the purpose of recovering the gold that they contain. I'm going to transfer the pieces into this melt dish now. Let's take a quick look at these pieces here. If you notice, there's some electrical components on the inside of the chips, and that's why we want to break them apart before we go to the next step, which is acid peroxide solution to dissolve out all the base metals. These don't need to be broke up real fine, just enough so we can get inside of each of these pieces here and get to the gold that's inside the chip. Now we're going to roast these a little bit with a torch here, just to burn off any oil and grease that might be on here. If you noticed when I started, the ink had been removed from the surface of the chip, and that's because I put them through my ultrasonic cleaner. Clean them up real good, the ultrasonic, before I started. Now that the chips have been burnt, to get off any oil and grease that might be on them, I'm going to add them carefully to this 2-liter beaker. So if I can do it without breaking the beaker. Look at that. Just wants to fight me. Now we're going to add some hydrochloric acid. This is hydrochloric acid from the hardware store. That's about 650, 700 milliliters of hydrochloric acid. Now we'll put in grocery store hydrogen peroxide, 3% hydrogen peroxide, about 250 milliliters. There's some little fibers floating around in here, and that came from the deteriorated seal on top of this bottle. That won't hurt a thing. Now we're going to put the lid on, stir this up. Notice how it's already starting to turn colors. We'll take it out and put the air bubbler in now. Okay, let's remove the cover. This is my stock pot, and what we'll do is just take the bubbler out of my stock pot, and then we'll set our beaker down here with our chips in it, insert the air bubbler, and let this react. I started this experiment on Sunday, 14 February. Today is Tuesday, 23 February. And it's been out here bubbling the whole time. So now what we're going to do is take it in. Let's look at it and see what we got. What we've done is removed all the base metals from the gold plating that's on these CPUs. But I want to double check and make sure we don't have any precious metals in solution. Should all be base metals, but let's check here. We'll stand this test. As you can see, there is 0 precious metals in solution. I'm going to filter this solution to make sure that we don't pour out any of the gold foils. If we do pour those foils out, I want to capture them in this filter. So here we go. We're going to filter our solution. Here's a look at our chips. I'm going to rinse the stuff off. You can see there's some gold foils in there. That's what we want to see. The purpose of the acid peroxide is to remove all the base metals out of here before we try to recover those gold foils up in there. If we tried to dissolve these CPUs without removing base metals first, then we'd have a very dirty solution and a lot more work to do here. This is going to make the recovery and refining much easier. Here's what we captured in the filter. I do see a couple of small gold foils in there. That black material's probably just dirt or something else, not precious metals. Let's take the flask out of the way, and what I'll do is put the filter down here, get this thing up out of the way, and I'm going to reach down in there, try to get those little foils and add those things to our main batch up here. See that? It's just a little gold foil that came off of the CPU. I'm going to add that back in here. I got another little piece in here. Add it back to the main batch. I'm not sure if this is going to be precious metals or not. I don't think it is. I'll have to make a decision on whether or not to add that into the refining here. But what I want to do now is reach down, grab one of these chips. Let's take a look at it. See if I can grab one here carefully. And there you can see the gold has come off of the CPU, the gold foils right here. This is carat gold. I don't know what carat it is. I think the trimmed fingers were 12K gold or 50%. So that's probably what this is going to be. So what we're going to do, put this back down in here. What I'll do now is turn some heat on back here. And we're going to add hydrochloric acid to the chips. The acid peroxide solution worked pretty good at removing the foil or getting the base metals out of there so that we could refine these foils. I'm fairly certain that this acid peroxide solution would work well for the computer pins. If everybody has those little pins that hold these chips into their sockets, if you got a bunch of those, you could probably use acid peroxide, let it bubble the solution for about a week, and then recover the gold foils from computer pins. Here's a quick shot of the gold foils from a different angle. First thing we'll do is add a little bit of sulfuric acid here. This will react with any lead that may be present in here, which is kind of likely because soft solder is used to solder computer components. The lead will combine with the sulfuric acid and form lead sulfate, and then we can easily and quickly filter it out of this 100%. I've got about 400 milliliters of hydrochloric acid in here. Now what we'll do is add some nitric acid to this. I'm going to add about 4 or 5 shots of this, 3 ml each, for a total of Let's do 5. And that'll be 15 milliliters of concentrated nitric acid that we've added into the beaker to form aqua regia. Gonna rinse down the sides now with some distilled water. I'm gonna cover this up, give it a stir, just shake it around a little bit like that, get everything stirred up. Now we're gonna put this up on the heat and let this react. Before I get too far into the reaction, I'm going to go ahead and add this filter just in case we've got any particles of gold in here. You'll notice the little gold foils and pins start dancing around and then poof, disappear right in front of your eyes. As the aqua regia heats up, those things are so thin that they dissolve almost instantly. It's been boiling now for about a half an hour. It looks like there's some insoluble material in there. I can't tell if it's gold or not, but I'm going to add another dosage here of about 2.5 milliliters of nitric acid. See what kind of reaction we get from this here. Foamed up pretty good, but I think we've got all the gold dissolved in here now. What I'm going to do is just leave this on the heat and let it boil now. Let that last dose of nitric react, and then we'll come back and take a look at this and see what to do next. This has been up boiling now for about 20 minutes after that last dosage of nitric. So what we'll do is we're going to pull it down off the heat now and let this cool down. I'm going to reach in and grab a little of this solution on a piece of filter paper here, and then we're going to test it to make sure we've got gold in solution. I've done these in the past, and I usually get about 0.3 grams of gold per CPU. You can tell by that stain we've got a pregnant solution with gold in solution down here. I've got a number 3 slow flow filter in here. What we're going to do now is filter the solids and capture the liquid down in our flask. The solids we're not concerned with. It's the liquid that contains the gold. That's the what we're trying to recover here is this liquid. It's kind of interesting here. These are sealed together with soft solder. Soft solder contains lead, and I think that might be the lead sulfate that we so often speak of when we add sulfuric acid to our reactions to precipitate out the lead sulfate so we can remove it from our gold. Alright, I've got all the liquid out of here now. I think we got everything that we're going to get off of these chips. Nothing left in there but the ceramic that the CPUs are made of. Here's what's left in the filter. I've pulled all the solution through that filter now. What we're going to do is transfer the gold bearing solution now into a clean beaker. I'm going to add some stump out now and precipitate out our gold out of this solution. Stump out bibonide. Got it at Ace Hardware. This is sodium metabisulfite. I'm going to add about 2 or 3 spoons to this solution now and precipitate out the pure gold. This is real time. I'm not speeding it up. I expect about 1.2 grams of pure gold from this many CPUs. You can see the solution is turning brown now as the gold reacts with the sodium metabisulfite and precipitates out of that solution. I've allowed the gold to settle overnight. Now what I'm going to do is reach down in here and get a little bit of solution on a piece of filter paper, and we're going to check this with stannous chloride and make sure that we've got all the gold precipitated out. I don't see any reaction. I've got a temporary waste container here that I'll pour most of this solution off into and save it. There may be small traces of precious metals in here. You can see the gold down in the bottom of the beaker. Here's our gold. I'm going to rinse it with a little bit of hydrochloric acid. Pour that rinse off into a temporary container here. I can see that there's some sodium metabisulfite in solution there. You see how milky and cloudy that looks. Let me let this settle out just for a second before we pour that off. Alright, I've got the gold to settle out a little bit down there. I'm going to pour this waste solution off. I rinsed it with a little hydrochloric acid and a little bit of water. Now I'm going to rinse with some, now I'll put another dose of hydrochloric in there and rinse it off real good. I think the that milky precipitate is just excess sodium metabisulfite. So we'll let this settle out again. Pour this off. Okay, we finally got the chemicals rinsed off, and the gold is settling out fairly quickly now. So we'll pour this rinse water off, and we'll get this gold into a melt dish now so we can melt it up into a little bead. Now I'll rinse the gold powder down into a melt dish, and then we'll take it over onto the melt table and evaporate off that water with those 2 torches and try to melt this up into a little bead. Now, in case you're wondering what happened to the sound, something happened to the mic. I either didn't have it on or something wasn't plugged in correctly. So I adjusted the PC mic volume down. Please let me know how that sounds. And this here is a little bit speeded up, about 2 times normal speed for this footage right here. This is a very small quantity of gold spread thin over the bottom of that melt dish. So here I bring in the oxyacetylene flame to try to get the gold to gather up into a single mass in the bottom of the melt dish. Here I remove the 2 MAP gas torches and continue the melt, trying to manipulate those little balls of gold into a single bead with the oxyacetylene flame. The gold finally started to form a little bead, and I used the pliers to maneuver the dish and maneuver the ball of gold around in the bottom of the dish to collect all the gold into that little bead there you see in the bottom. Here I am on the home stretch. I've got the gold to come together and form a little bead down in the bottom of the melt dish. Now we're going to reach down in there with a pair of metal tweezers, pluck it out of there before it glues into the dish from that borax. And here's our little bead of gold. Man, that's a tiny little bead for all the work that we put in on this project. This is a good example of why I don't refine much computer scrap. The yields are just too low. That bead looks so small. I wanted to check my waste container, and here you'll see some of the gold ended up on the bottom of that waste container. Here's our little bead of pure gold. It's not very high purity. I was expecting 0.3 grams per CPU. Let's see what kind of weight we got. Half a gram, 0.5. That's less than half of what I was expecting. And this is why we don't refine much e-scrap, because the yields are so low. This is not going to be high purity gold. I can tell by the color. It's still got other metals mixed in with it. We'll throw it in with the next batch of carat scrap that we do and re-refine it. All right, this will conclude the video. Thanks for watching.